Okay, this is the P4 paper from October 2020. It's question number 6. This is going to be a differentiation question. We're going to be finding stationary points. And when we follow this process through, we'll actually see that we're going to need to do some differentiating parametrically. But let's have a look at the question and make a start. And it is a very scary question when we look at it. For part A, it says y is equal to x to the power of sine x, where x is greater than 0 and y is greater than 0. Don't lose out on those two while you're panicking about the fact that you've never seen x to the power sine x before, I would imagine. No idea what the curve's going to look like. But that's okay. Let's see whether we can follow the examiner's instructions through and see how difficult this works out to be. Really good example of one of those sorts of questions where just go as far as you can go and then start panicking once you don't know the next step to do. I know the next step because it says take natural logs. So I'm going to log both sides here. So I'm going to get log y is equal to log x to the power of sine x. Well, as soon as I see that, this is absolutely jumping out at me that I can use the log rule with powers to bring that sine x down. So again, don't panic until you have to. Let's just get here, sorry. So we've got log y is equal to sine x, log x. And now I feel much more comfortable with this. I need to differentiate. I need to find dy by dx. So I can differentiate this side parametrically, and I can differentiate this side because this is a product, and if I'm differentiating a product, I'm going to use u dv by dx plus v du by dx. So let's do that straight away. Let's not worry about it. U is equal to sine x. So du by dx, differential of sine is cos. V is equal to log x. Differential of log is equal to 1 over x. All that should be straightforward to you at this stage of P4. So when I'm differentiating then, differentiating this side, the differential of log y with respect to x will be 1 over y, but then obviously we need to include a dy by dx for all our y functions. Differential of sine x log x is u dv by dx plus v du by dx. I don't think you necessarily need to write this in, but it's just for people who might be a little bit stuck at this stage. Is equal to u dv dx is those two, so that's going to be sine x times 1 over x plus v du dx is the other two, those two. So v dx is going to be log x times cos x. So if I'm tidying that up, I'll just do one quick step first before I multiply everything by y. I'm going to call this sine x over x. You don't have to, but certainly here, I'm going to call that cos x log x, because I don't want anybody thinking it's log x cos x, which it certainly isn't there. So that just means I'm less likely to do that. And then dy by dx is equal to, just multiply out by the y. So y lots of sine x, excuse me, handwriting, sine x over x plus cos x log x. And that's it, because it just says find an expression for dy by dx in terms of x and y. I don't need to do anything more complicated than that. And look, I've suddenly got those 5 marks just by persevering and not giving up too early with it. Okay, part B. What does part B say? It says show that the x coordinates of the stationary points are the solution of this equation. Right, so in my mind what I'm thinking, I know what stationary points means dy by dx equals 0. So I'm going to put this equals 0. When I'm trying to solve this equation then, it looks like I won't be able to solve it fully, but I will be able to get it to look something like that. So I've got to have that in my mind as I'm going through. I've got to have tan x or x log x in my mind as we're going through and doing it. But let's tell the examiner what we're going to do. So for part B, what we're going to say is, for part B, at stationary points, dy by dx is equal to 0. So if dy by dx is equal to 0, then that's going to be equal to 0. So if that's going to be equal to 0, we're going to get y sine x over x plus cos x log x equals 0, which means either y is equal to 0 or sine x plus the well, in the bracket, sin x over x plus cos x log x is equal to 0. But this is where what we needed to do was just be aware of the first part. On the first part it says y is greater than 0. So I didn't forget that when I was panicking. So here, y is greater than 0, so it has to be then that sin x over x plus cos x log x is equal to 0. I've lost the ability to write there. So if that's true, what I can do at this stage, and this is only really because I'm looking back at my answer, is I can divide by cos x. Now, why am I going to divide by cos x? Because I want to get rid of that one, and also that will then make sin x over cos x, which will make tan x. So divide everything by cos x. Understand that you might miss that step, but if you do that, sin x over cos x becomes, well, let's just write it all out. So that's 1 over x sin x over cos x plus cos x over cos x log x equals 0. Then that can go, that's going to become tan. So I now get tan x over x plus log x equals 0. When I look at the answer, okay, yeah, now multiply everything by x, and again, you can do that, x is not equal to 0. So multiply by x all the way through, and I'm going to get tan x plus x log x equals 0. And then that's actually what we wanted there. So there were two steps that we did, dividing by cos x and multiplying by x. Both of those we could do because we knew that x was greater than 0 and y was greater than 0. So there's no problem to do either of those two things, and then we get to the last part of the answer. Yeah, quite a tricky question, but one to look back at and to use really more than anything else. When you actually come to do your exam, don't panic when you're sat there and you think, I've never seen this before, this is new to me. The examiners have the right to do that as long as they're reasonable steps to go through and be able to solve the question. This is an exact example of one of those. So hopefully that makes sense, and hopefully you can use that moving forward.